Okay, don't laugh at me. I decided to do one more set of random problems, but now I can talk because now I'm downstairs and I don't think I'll have any interruptions. So what I put was advice to you is to try the problems by yourself. They're pretty random off the top of my head, different types of problems that we've been working on. So, feel free to press pause. Feel free to mute me. It's fine. Let me just adjust myself so I am a little comfortable here. So this first one we're going to simplify, which means I'm going to try to break it down into perfect square and leftover. If you are not good at finding perfect squares, there is another method you can do, and that includes breaking it down as if you had a factor tree. That 96 actually breaks into 8 times 12. I had a little... Oh, my brain got tired for a second and I didn't know. Excuse me. So 96 breaks into 8 and 12. 8 breaks into 4 and 2. That breaks into 2 and 2. So we have some 2s. This breaks into 2, 2, and 3. So we got some more 2s. So it looks like there's 5 2s and a 3. So what you could always do is break it down using a factor tree. And that includes the variables as well. And from there, because you're looking for perfect squares, and you did see this in one of the ed puzzles, is you take out one pair of 2s. So that goes to the outside as a 2. Because what I just circled really is a 4. Square root of 4 is 2, comes out. Oh, there's another pair that's coming out. I see a pair of p's. I see another pair of p's. So what's left is 2 times 3 is 6p. So to write this a little nicer, you have 4p squared radical 6p. Not all of you will do it that way. Some of you will see that the perfect square is 16. So 16 times 6. Square root of 16 is 4. There's your 6 left over. And you'll be able to work it that way. That's just another approach, just so you know. So we have 2 square roots being multiplied. That 8's kind of weird on the outside. I'm just going to multiply underneath the radicals. So I have 8c squared. I'm going to take out the perfect squares, which are 4c squared, with a leftover of 2. So I can see that the 8 breaks into 4 times 2. C squared is already perfect. So this comes out as 2c times the 8. So you're done. Next one. We have, I like to change up my colors, you know that. Add some excitement to my fun Saturday night here. These are both perfect cubes. So kind of the same idea as this. If you want to multiply 50 times 20 and try to figure out if it's perfect, you can. Actually, that works out really nicely. We should just do that. Because 50 times 20 is 1,000. And I happen to know that 1,000 equals... Ooh, how about that? Now, you might not have seen that. There's different ways to do it. You can either break it down, or you can use a calculator just to see if you can figure it out. That's a pretty big one. 1,000 also has, if you broke it down, it would be 8 times 125. Those are also perfect cubes. Take them out, you have 2 times 5, which is 10. Anyway, so you get this. So we end up with 10. And I can take a group of 3 of these out. And that means 2 are left over. So that's it for number 3. Number 4. Hold on, I'm going to put the cap of my purple pen on because I don't want it to die. So 4, I'm going to distribute the radical 3 in. So there's still a 6 here. Radical 3 times radical 3 is radical 9, otherwise known as 3. So that's that first part. Minus radical 3 times 3. That's how we write it. So your answer to this problem is just Obviously, as usual, feel free to call me out if I've made a mistake. Ooh, you guys love these problems. Sometimes when we have these, we think we can do this in our head. I know better. You guys have already heard me yawn 3 or 4 times. I'm ready for another one now. It's only because I mentioned it. But if I don't write out what I'm looking at, I'll never be able to do this in my head tonight. This is what squared means, though. So I'm going to multiply the first term. So 2 times 2 is 4. Radical 6 times radical 6 is 6. So 4 times 6 is 24. And that's all from that first term. The outer terms, I have the 2 times the 4, that 2, and that 4, which is 8. And radical 6 times radical 5 is 30. 30 is one of those numbers which you think it could break down, but it can't. Just so you know, it does not break down. The inner terms, negative 4 times 2 is 8. Radical 5 times radical 6 is radical 30, so that's another negative 8 radical 30. And lastly, we have a negative times a negative. So it's going to be a plus. I better write that. 4 times 4 is 16. Radical 5 times radical 5 is 5. 16 times 5 is 80. So the answer to this problem is... Oh, I hear a kid coming down the stairs. Unless that's the dog. Oh my God, that's the dog. Phew. I can carry on, people. There's the dog. See? Hello, dog. Anyway. Now we have cube root of 12 over 6. Which we can simply do that. That is so legal to do. It's nice when you can do that. It makes your life a lot easier. Number 7. So we have radical 10 minus radical 5 all over radical 2. None of these are like. You cannot combine these two things. The only thing you can do is try to get that radical out of the denominator simply by doing that. Notice I put the parentheses on the top. That's to remind me to distribute. And it's not going to go any further than this. This does break down into that. So you get 2 radical 5 minus radical 10 all over 2. That answer is much prettier to a math teacher than that one, but I can't cross anything out. You cannot just cross out those 2's on the outside. You would need a multiple of 2 in front of the 10 as well, just so you know. So I think I have 3 more problems. So 3, oh sorry, number 8 I mean. There's 2 parts to it. I am going to rationalize that. Notice these don't just cancel. I know some of you were canceling, I saw in the Ed puzzle or whatever else I was looking at. No, it was the rad ops, the one written in red. People were canceling this. Radical 2 times radical 2 does not cancel out. It becomes radical 4, which becomes 2. It removes the radical sign. So this is legal. That first one just equals that. Plus, well, let's see what happens here. I have 3 radical 2 times 3 radical 2. 3 times 3 is 9. Radical 2 times radical 2 is 2. So 18. That's your answer for that one. 9. The only way to eliminate that radical in the denominator is to multiply by the conjugate. So I have to distribute on the top, so I get 36 minus 9 radical 3 all over. And on the bottom, when you're multiplying conjugates, yes, you are doing this. What's going to happen, though, is that those 2 middle terms, that 4 radical 3 and the negative 4 radical 3, are going to cancel out every time. So sometimes Mrs. Collins gets tired, like tonight, and just does the first term and the last term, because I know the middle are going to cancel out anyway. So this gives me And the last one, same idea. No way. Do not do that. I know it's tempting. You cannot cross those things out. We went through a whole... Oops, I put plus. I didn't mean to. That's a minus sign. We went through a whole topic where you had to factor before you could cancel things out. That was quadratics. This is a little different, but you can't just cross out parts of things. So I've got this set up now. There's some parentheses. So we're going to FOIL the top. So I get 24 minus 8 radical 2 minus 3 radical 2 plus 2. And on the bottom, I've got my first terms. My outer and my inner are going to cancel. So I get that. So my final answer for this problem appears to be 26 minus 11 radical 2 over 7. Okay, I'm tired.